Following the developments of recent years, we all agree that SDN is the future of networking and the era of proprietary black boxes has run out. By following these strategies, besides sheer bandwidth and computation power, future latency requirements come into focus as well. Enter OpenSDNCore, a versatile software toolkit from Fraunhofer FOKUS that addresses flexibility requirements in future network setups. However, through the obvious disadvantages of commodity hard and software running on x86 servers, like low network throughput resulting in higher end-to-end latency and the general lack of processing power in the signal processing and security domain of the data plane, the exorbitant magnitude of data centers with virtually endless racks of x86 hardware seem to be the price to pay for the invaluable gain in flexibility. Let's combine Fraunhofer FOKUS OpenSDNCore with dedicated accelerator hardware from CarrierConnect in the form factor of standard PCIe boards, integrating seamlessly with OpenSDNCore, leveraging unparalleled flexibility combined with wire speed data plane latency under 1 millisecond and multi-gigabit throughput between in- and egress NICs. Here's what we did to actually present to you the advantages of acceleration PCIe hardware in software-defined networks. Integrate a multi-core packet processing backplane into OpenSDNCore. The challenge we faced was to chain diverse network functions via an open vSwitch, whereas the latency between the ingress of the packets and the egress should be clearly below the maximum value required in 5G, which is 1 millisecond. All this in virtualized environments and in the range of up to 40 gigabits per second network chaining throughput. To prove our claims, we built a testing environment to show how offloading network traffic to dedicated hardware affects the benchmark data of the computing environment. Starting with a baseline measurement, we see the latency of around 0.04 milliseconds at a constant throughput of 0.52 million packets per second, which will result in a net throughput data rate of around 37 gigabits per second. The following results depict the packet forwarding measurements within virtualized environments such as KVM. The comparison shows the difference between the non-offloaded forwarding on the left side and the offloaded forwarding on the right side. The comparison shows a clear difference in latency where the accelerated setup is 50% lower than the non-accelerated one, and the accelerated setup increases the throughput by 255% over the non-accelerated one. The saving in energy consumption is about 30 watts. With no remarkable rise in complexity, the accelerator hardware integrates nicely with OpenSDNCore. Since data plane data predominantly is switched and processed directly on the NIC without the need to enter the host and VM guests back and forth, the capacity advantage over a non-accelerated commercial off-the-shelf server can be from 1 to 5 up to 1 to 10, depending on the deployment scenario. What does that mean for future deployments? One accelerated server can replace up to 10 conventional servers. Besides living green IT, CAPEX and OPEX change for the better significantly. Future, lowest latency requirements can be achieved even in complex, large-scale deployments.